Hello, welcome to my space station. If you're being updated on the news recently, you would have most probably heard of 2024 YR4, or if not by the name, then you would have probably heard that there is an asteroid which will come pretty close to Earth in about 7 years. Well, in this video, I will try to give you as much information as is publicly available to us as per this asteroid. So let's get started. So what is the risk with this asteroid? Now, I mean, near-Earth objects pass pretty close to Earth all the time. Sometimes they come between Earth and the Moon's orbit. That's when they become a bit of a threat. Now, what is the special thing about 2024 YR4? I will just refer to this as YR4 for the rest of this video. Now, the danger that comes with this is that its chance for impacting the Earth is higher than any asteroid that we have ever seen. It is 2.4%. Around that, and that is actually a lot. Now obviously in the real life, like in your day-to-day life, 2.3, 2.4 may not seem like much, and 2.3 is not a perfect value. Some space agencies calculate it differently. Some give a higher chance, some give a lower chance. The ESA, the European Space Agency, notoriously gives a 1.6, while other space agencies like NASA and the organization that actually found this asteroid give it much higher. Now let's just take 2.3 for the rest of this video. Okay, so what is the risk that is associated with this asteroid? It's that it's going to come dangerously close to Earth in the year 2032. Now this asteroid has an elliptical path, okay, and there are points where it does come close to Earth, and it makes a close flyby of Earth every 4 years. So we will see this asteroid again in 2028, but it will not be as close. The real time when the asteroid becomes a threat to Earth is going to be 2032. Now, why is this a threat to Earth? Well, the asteroid itself is 30 to 40 meters wide, okay? And if it impacts Earth, the energy released would be equivalent to 8 megatons. Now, for context, the Hiroshima nuclear bomb, the bomb that was detonated on Hiroshima, this 8 megatons is more than 100 times powerful than that, but it is also less powerful than the most destructive nuclear weapon known to mankind, which is the Tsar bomb. So it's up to you to take this as good news or bad news. But the destruction will be pretty significant, up to 50 kilometers from the crash site. So it is not something that you can just completely ignore. And another reason why we are tracking this, why we are so interested in this, is that even if, let's say, it doesn't hit the Earth, okay, this will still give us a lot of insight to how these bodies in space actually orbit, right, into their composition. Let's say if it comes pretty close to Earth, maybe we can understand asteroids better, what they're made of, their composition. And we can also use this as a kind of, like, since this chance is not that high, okay, it's pretty high but it's not that high, in case in the near future if any asteroid comes even more closer to that, which has a chance of hitting us, the chance of hitting us is more, we can take this as practice to rehearse what we would do in those scenarios. Now, what are we going to do to combat this right now? Now, if you are like being updated on space news and watching my channel, you would have heard of DART. Okay, so DART was basically a mission by NASA to launch a spacecraft and to collide that spacecraft into an asteroid to change its trajectory. Now, what happens is that in space there is nothing to slow momentum down. If you apply force on an object, there is no air resistance that you have on Earth that would slow the object down, and there's no friction. So usually the object would just keep moving in that direction, okay, forever. Thing is that now you need another force to exert on that object to slow it down, okay, and slowing that down would eventually change its trajectory in the long run. So this is a game of patience. In fact, matters that concern space are just patience, because you do something and then you have to wait a long time to know if it worked, a long time to get the like, let's say that you launched DART, right? It took a long time for it to reach. It took a while for it to maneuver, and like there's a lot of precision involved also. So this is just a game of waiting. So how are we going to combat this? Now, we could try a method similar to what DART did. We could launch a spacecraft that would hit this asteroid, and this could change the trajectory. but the asteroid is pretty massive compared to the one that we have tested DART on, so we are not completely sure if it would work or not. There have also been proposals of launching nuclear weapons at it because it's a big threat. But there is one big issue with this. I think I've already discussed this in the video which I made on DART. But the main issue, I'll recap here, the main issue with launching missiles or nukes or these kind of destructive weapons is that you will change the trajectory by a lot, but you will also release a lot of these toxic chemicals, and you will release a lot of debris into space, which could end up, if not harming the Earth, the satellites around Earth. Let's say the asteroid is coming, you launch a nuke, okay, asteroid, the trajectory is changed, but there's a lot of debris, and that debris, okay, may not pose a danger to Earth, okay, but the satellites in Earth orbit, they may be hit by that debris, and that would cause a lot of damage. That's why we would not want to use a missile or something like that unless it is absolutely necessary. So we have a lot of time, okay, we have a lot of time, and there have been proposals to even try to use a method by putting a massive object around an asteroid. This is actually another method of changing the trajectory, but it takes longer, as it depends on there being a massive object next to that asteroid that would, over time, the gravity would change the trajectory. Now this is probably will not be applied because 7 years, I don't think so it would work. And thing is that this is a pretty recent discovery. This asteroid was only spotted in December 27th, 2024, and it was really classified as a dangerous object in just yesterday, actually, January 6th to 5th. It was classified as type 3, okay, which means that it's pretty dangerous. So the research on this, okay, and the the international communities, like what they're gonna do to combat this threat, it's still underway, and we don't even have much information on the basics, because see, we just spotted this, we just classified this as a threat, and the thing is that this asteroid is racing away from us. We just have a few months to make all of the measurements, to make all of the observations that we can with our ground-based telescopes. The issue is that after a while this will be out of the reach of our ground-based telescopes, and that is why for a while NASA will use the James Webb Space Telescope to track it, and after that we will lose sight of it, and then we will only see it again in 2028. That is when we can make our final preparations for its approach in 2022. So that is all the information that we know until now, and I guess if more relevant information and more information that would change the gravity of the situation around here, I will definitely release it on my channel. And I'm just updating, this is a video just to update you on what's going on, to let you know that there is a rock coming for you, it may hit you, so just be ready. So that was all for today, and I hope that even if it does not collide with Earth, I hope we can learn a lot from it. I hope we can learn how to deal with emergency situations like this, and I hope humanity will come out a better humanity after the asteroid has passed by Earth, or after the asteroid has leveled a city. Thank you.